All right, so you should have just gone back from your canvas and saw graphs that looked something like this. Mind you, not perfect. And the second one looked something like this. And your third one should look something like this, right? The first question asked you to create something. I'm drawing this wrong. I'm sorry. Hold on. Let's try this again. The first question asked you to create something with a negative correlation. The second one asked you to create something with no correlation. And the third one asked you to create something with a positive correlation. So you should have something that looks kind of like this, right? It's not going to be perfect. It's not going to be exactly the same. But your negative needs to go down as it moves to the right. Your no correlation should just be a sneeze. And then your third one should be a positive correlation as it moves up and to the right. Okay? That's all correlation tells us, right? This is negative. This is none. And this is positive. Right? So, next thing, we want to be able to make a scatter plot, and we want to be able to draw in a line of best fit. So, let's take a look at this example here. The table below shows the lengths in centimeters and swimming speeds in centimeters of 6 different fish. It says draw the scatter plot. So here we go. Notice that I've got lots of really large numbers and things that don't necessarily, I don't want to number this by 1 because that's not going to work real well. I know that my x-axis here is the length, and I know that my y-axis here is the speed. So I need numbers that go up to 40, as low as 19. So I think I'm going to go up by 5s here. 5, 10, 15, 20, 25, 30, 35, 40. Right, so we'll label those. And then dot, 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 that's all the way up to 20, 25, 30, 35, that's 40 over here. My speeds, I've got numbers as low as 47 and as high as 150, so I need to make that scale a little bit bigger. I'll probably go by 20s. 20, 40, 60, 80, 1, 20, 40. So this is by 20s. And it's okay to have them have different scales. We need them to scale appropriately. Okay. So let's go ahead and mark things off. So this first point is 37.8148. That's going to be about here and about there, right? We are getting as close as possible. We need 19.247. 19.2 and 47 is about right there. I'm using a different color for all of these so you can see what we're doing. 21.3 and 88. 21.3. 88. Right about there. Stop that. Right about there. Then we've got 26.2, 131. 26.2 is about there. And 131 is about here-ish. And the last one, we'll do in the blue, 26.8, so right around there again, and 98, which is about here-ish. So there's my scatter plot of those values. Notice that we have a positive correlation that the bigger the fish is, the longer the fish is, the faster it swims, which should kind of make sense there. And if we're drawing in a line of best fit, we're going to draw in a line that gets as close to as many points as possible. So you can kind of see how it goes up here. I don't want to go straight up because then this point would be kind of lost. I want it to get as close as possible to as many points. So notice that this line doesn't actually go through any of the points, but it does get the closest to all of those points. So that would be my line of best fit. Right in there. So what is it? So when we're looking to make lines of best fit, if it shows a positive or a negative association, we model it with the line of best fit. And the line of best fit is that it gets closest to all the points in the scatter plot. So we make the scatter plot. We make sure that it's vaguely linear. And then we draw a line that appears to fit the data closely. It should be there should be approximately as many points above the line as below it. So let's look back at that last example. We've got 3 above it, 2 below it. That's pretty good. And it's just about as close as we can get to all the points. And then finally, we can write an equation using 2 points that are on the line or 2 points that are very close to the line. We're going to do that in the next example. But so we drew the line in there as close as we possibly could. Okay? Let's do this last thing together here, and this is all we've got today. So this table here shows the number of active red-cocked woodpecker clusters as part of the DeSoto National Forest in Mississippi. Write an equation that models the number of active clusters as a function, the number of years. So notice that it's asking us to write an equation here. We should graph all these points, and then we should draw the scatter plot, graph points. Is it relatively straight? Draw the line in, and then create the equation. So let's draw the scatter plot. And what I'm going to do this time is I'm going to draw just the top right part of the graph, because that's all I need. But for the year, I don't want to deal with 1992 and 1993. So I'm going to label this one down here, years past 1990. That way that I can, if I do it this way, I can mark these as 2, 3, 4, 5, 6, 7, 8, 9, and 10, which is better than doing it in the thousands. So I can mark this stuff as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I don't have to do any special scales. Just kind of makes it a little bit easier. Let's see, we need to go from 20 to 50 here. Let's see, we can do that by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And let's mark our points. This is 222. 222 is about there. And then 324, about there. And then 427. I'm gonna label these. Make it easier for me to mark them. There's a lot of like little attention. What? 27, 30, 35, 40, 45, 50. There's a lot of like little attention to detail things when you're making these graphs. 427, 427 is about there. 527, so 527 is about there. 634, 634 is there. 740, 740, 842, 842, 945, 945, and 1051. And again, notice these are not perfect, right? This is not a perfect line, and it shouldn't be. But is it vaguely linear? Can we model it with a line? Absolutely we can. So we're going to draw on a line that gets as close to as many points as possible. It doesn't go through everything, but it does go through a few. It's fairly close to everything. So there's my line of best fit right here. Line of best fit. Now, can we create an equation for this line? And the answer is yes. And what we do is we pick 2 points that go through this line, 2 points that are really, really close. So I notice that this point is basically on the line, and this point is basically on the line. So I'm going to take those 2 points, and I'm going to make an equation out of them. So this one was 1051, and this one down here was 324, 324. And now what we're going to do here is exactly what we've been doing in every other lesson so far this unit. We're going to find the slope. We're going to then plug that into y equals mx plus b, and we're going to get our equation. So my slope is 51 minus 24 over 10 minus 3. I'm going to do this part kind of fast because we've been doing this. So this is 27 over, what is that, 27 over 7. So it's kind of ugly, but that's my slope. And so let's pick a point here. And I'm going to go with, what point do I want to go with? Let's go with 324. So this is, we're going to plug it into y equals mx plus b. This is 24 equals 27 over 7 times 3 plus b. You know, at this point, when we get something this ugly, let's use a calculator. Where's my calculator? I lost my calculator. I'm going to do it on my phone. So maybe I'll do it on my phone. Isn't this blank time just great? I'm super prepared. Okay, here we go. So 27 divided by 7 gives us this ugly number, times 3 gives us 24 equals 11.571 plus b. And then I'm going to subtract that. 24 minus 11.571, right? Because we're subtracting 11.571 from both sides. And we get b equals 12.429. So there it is. That's my equation. There's my y-intercept. There's my slope. So what's my answer? Y equals 27 over 7x plus 12.429. Whop. Notice that when you do lines of best fit, you get ugly, ugly numbers. Use your calculators. It's okay. This is the one case where it's okay to be using decimals for this stuff because these are ugly, right? Real life is ugly, and so you just kind of have to use a calculator to get through it. All right, that's it. You got an assignment, a couple problems to do where you're going to be modeling some stuff, and yeah, there we go.